So there is a power outlet, right? Power inlet, so that you can plug this and connect it to your PC. So I'm going to close this. Let's get familiar with this IDE. There are menus on top. I think 1.8.0 or 2, hopefully the same.
Yeah, but don't continue over there. Let us download first, because then we're going to be far behind. Seriously.
I know you are so smart to do multi-processing. So while you are doing, you can also hearing my explanation, and also you're watching something else,
No, I'm
and
not.
you are thinking something else.
No, I'm not, seriously. But he's downloading it, so now I'm gonna listen to you.
Sure. So you can see, I want you to take a look at menus. So there's a new open recent, sketchbook, examples. There are a lot of examples. So you can download some. You can take a look at some of the examples here. See a lot of examples. Last semester we did RF24, right? There's AES library for cryptographies, and wire, SPI, software serial, EEPROM. If you want to save something on your microcontroller here, this one has 256K memory space, quite big. And Wi-Fi. Right now, this is not Wi-Fi Arduino Uno. I ordered Wi-Fi Arduino Uno Wi-Fi. Personally, I purchased during winter break, so that only this semester I placed the order of Arduino Uno Wi-Fi. But all of a sudden, discontinued. I do not know. There may be some issue. I'm not sure. Technical issue or something else. But I have. It is powerful. It is connected to your Wi-Fi router and do some great thing. These small things can do.
To Wi-Fi router or to your computer?
Here itself. This itself receives Wi-Fi signals.
Yeah, from your computer, like you're saying to connect it through Wi-Fi with the computer and code it?
No, without computer.
Oh.
So, what language is this programming language that
C.
Arduino uses?
C. But you can import Python. Basically Python or C. Same thing, Raspberry Pi. It has C or Python. What is that?
A flight. See, he's used to Yeah, got one.
He got a good actuator. What's that one?
Yeah, what? I'm sorry.
It's good.
There's
This is
something-
good. And that bugs.
Where's the net?
I was sitting here from 250. Multiple times it hit me. Scared.
And once it came to creation, by the way,
Vigos or the, you know what.
So I owe one bulb to Croatia.
You owe 5 credits to him.
Oh, sure.
5%.
Great. Okay, so I wanted to take a look some of this. So examples,
I don't think that's it.
GSM.
You sure?
We don't do much.
I know, but yours is a sketch. This is not the
Right.
sketch part.
And then edit. Here we do some and sketch, verify, compile, and upload. Those two things that we need to do. And tools.
For what? For your phone?
Board needs to be identified.
That's for your phone?
Okay, this is one thing very, very important. All right. So I want you to here. You have to follow at the right pace so that we can finish up before 9 o'clock. So hands-on takes longer and longer. Okay. Are you all almost done about download ID?
We downloaded it.
Yeah. Connect it.
Yes, sir.
Connect it to your laptop. And then here in tool menu, go to tool menu and down. Then there is a board selection. Board. Make sure that you have Arduino Uno. Okay, Arduino Uno. Arduino or Genuino. Anybody here knows Roman, Italian?
Italian?
You're close to Italian, right?
Yeah.
What Arduino means? Or
I can search.
Genuino.
Is this, Professor?
Huh?
Is this a sensor itself? What is
No, there's a microcontroller.
microcontroller?
Yeah, I'll give you a sensor in a minute. If you look at this, I'm going to explain this for you first.
Everything is there, right? Like even.
Yeah, you can. There are 13 to 15 pins. This is digital pins for input or output. There are 5 pins, 6 pins for analog input. Okay. So A0 to A5. That is analog in. There's a digital pins 0 to 13 or 14, 15, yeah, a little more pins there. There is a digital. These digital pins can be used for input and output. And those digital pins are PWM. PWM means pulse with modulations. So pulse, that's a digital. It means digital. And some lights on. Find out there's a TX on something. And then there is a some rectangular, like a memory-like processor. This is an EEPROM processor and processor in it and memory also.
In Italian means strong fan. Strong fan.
Arduino means
Arduino means strong fan.
strong fan.
Strong fan, yeah. Strong. Yeah. Or genuino means genuine.
Genuine.
Yeah.
Genuine. How come they come together? Strong, I mean, Arduino and Genuino.
That means genuine strong friend.
No, I mean genuino probably it's another.
There's a one or the other.
Yeah.
It's Arduino
another,
or
yeah,
Genuino.
It's different device.
For different purpose?
They're the same. That's what they do. Okay, so when you have a sensor, then we need to sensor, if it needs power, most of the power needs power. Most of the sensor needs power. So we have here, look at the power, the left side, not the digital side, not the longer, the more pins side, but the smaller pins. There's a reset 3.3 volt, 5 volts, and 2 grounds. So 2 grounds and voltages needs to be a power supply. And one of the pin here in the digital pins, if your sensor has data outlets, then you need to jump that data outlets to one of the pin here, digital pins, and in your program, you need to identify, you need to specify, hey, I'm going to listen, I'm going to read this particular pin that I connect from my Arduino Uno to the sensor. Okay, that is the idea. All right, so I wanted to make sure that you have that board and port. You need to see COM port 1 usually is not for your Arduino Uno, but you have to find out if there is another COM port. It says Arduino or Genuino Uno with the COM port label, then click on it. So that when you come back here tools, that you have to see, oh, there is a board, there is a port. Make sure those two elements filled in. Okay? All right, then sensor that we are going to practice today is this. Arduino Uno HCSR04 ultrasonic sensor. So this is the sensor. I'm going to give to you.
And the cables, you need help?
Oh yeah, this is
I'm going to use one of those and one here. And you need to unpack it. If you see this, there are 4 pins. In your sensor, there are 4 pins, right? The one of pin that is the ground, and one next that is the echo, and the other one is trigger, and then at the other end there is a VCC. So VCC and ground, 2 pins for the power supplies. VCC, then you need to link with how many volts? I think 5 volts. 5 volts needs to come into this VCC, and ground for connected to ground. Okay, so I'm going to give it to you.
Yo, which pins here in the Arduino are for ground and for VCC? How do we know? Which pins are here for ground and? Yeah, one is for ground, GND, yes, and then the other one is Echo and V stuff. What is that? Yeah. Yeah, bro. VCC, which one should you choose? 5 volt or 3
5 volts.
5 volt, okay. Yes, sir.
5 volts.
Yeah, but no, don't put it because he's gonna give us the cables.
Let me choose first. You have to choose this very carefully.
Otherwise, we're gonna burn.
No, not because of that. There's a male and female. Here is this. Look at this. Your sensor already has pins. These are male, right? So at this end, you need to have a female. Don't be laughing. And then your Arduino, Uno, they're all female. So you need a male. So your jumper cable should be one side female and another side male. That I picked here like this. Male and female. 4 of those. I have a bunch of it here, but they are not all male and female. Some male, some female, some male. How many combinations?
3 combinations.
3 combinations. You're very good. So pick 4 cables.
Alright, sir.
And then be careful that the cables should be plugged in the right connection. Okay? If there is a ground, it should be ground to ground and voltage to voltage. And then this guy has 4 pins, so 2 pins for the data, right? Remember that this ultrasound distance sensor needs to take 2 data. So one data from chirp signal, the other data from echo signals, and then compare those 2 signal difference and convert that to, and then you have to some compute to measure the distance. Okay.
Downstairs. One should go ground, 154.
Me here?
Mhm.
And then these, we're gonna go into a,
You need to have one
We need-
different. This is a male.
we need to,
This one. And then these 2.
This ground to ground
yeah.
and voltage to voltages.
No.
Echo goes to 2. Echo goes to 2. Wait, it's not. It's 12 or 2?
No, it's 3 and 2. 2. Digital 2.
12. It's 12.
One super box. Yeah, 13, 12. Yeah, 12 and 13. Yeah.
So wait a second. Echo, where is it going, Echo?
This is equal.
And it's going to 2, right?
Yeah, it's going to 12.
12 and 13.
Yeah.
Okay, now what do we have to do?
And then trigger pin and echo pins.
Yeah,
Echo pins.
Echo on 12.
Echo 12 and trigger 13.
Yeah. Now we connect, right?
Okay. After that,
What about the other 2?
you have to do new. If you have anything here already, then ignore and click new. So that you need to have new editor. So I'm going to close something that I have already. And I need to make sure that I have board and port. That's okay.
Yeah, 12 and 13, yeah. What about the other two? The ground goes to here. On the other side, ground, you see 5 volt and GND. You see?
GND, yeah.
GND and 5 volt next to each
I have
other.
to go catch the train.
Yeah,
and then 5 volt.
Look, GND from here.
I'll show you the next Thursday when I have a
From
project.
here, GND goes to GND.
I have still a lot of work to do.
Look,
Okay.
So,
which one is GND?
so can
The brown?
so can my master's project substitute the class project?
One close to anyone. And then the
Oh, if
5
you do
volt
this,
goes here,
great.
To VCC.
I mean, great extension.
You have 5 volt. Yes.
What do you mean?
Not the
But
minimum
it's not turning on, mine.
But I don't have much in being
further.
Yeah.
Yeah, just
Of course.
Express.
Yeah, of course, then you can do.
Yeah.
Because
It's all Swift language.
Okay.
Sure.
Thank you. I'll see you. Have a great Easter, guys.
Hey,
All
see
right.
you. Happy Easter. Let me know about that, huh? Please. Tickets. Officer, mine is not turning on.
Which one?
The Arduino. No. Oh. Yeah. Yeah, a little bit.
Is it connected to your laptop? Okay, let's move. Otherwise, we cannot finish. I think. Yeah. Let me go. Let me do. Okay, you follow. If you see this editor, then this is very important. You have a void setup. There's a setup block. Here there's a open curly brace and close curly brace. We have nothing in it, right? So there's an empty block for setup. We have another empty block for loop. Here, loop, right? Let's practice one here. First thing that we need to practice here is that I want to do serial dot begin, and then 9600 baud rate. Back here, loop. I want to do serial dot print ln. I want to do hello. I am here.
Does that say serial dot what?
Serial dot begin and serial dot print ln.
Print ln.
And then all should be ending semicolon. Okay. So 2 lines each. What it does is that
Is that a semicolon or a colon?
semicolon.
Semicolon?
At the setup, you need to set up the communication. Communication between communication from your here Arduino Uno. Okay, communication.
This is not working. It's not our fault. This was the old one that you gave to me. It wasn't like this.
Can you indicate this so that I need to? How do you know it is not working?
Because it's not turning on that. When I took theirs, it's working.
Okay,
So I'm gonna try this one and see,
sure.
because I wanted to
Yeah.
know if the Arduino board
Yeah.
is wrong or that one.
So I'm going to. Okay. All right. After that, there is a tools, and there is a serial monitor. If you see the serial monitor, it's a serial. Serial means we set up serial, right? Serial begin, so baud rate is 9600, and serial printout. I want to print out this text in the serial line. So let's see. I want to open serial monitor. Bring here serial monitor. And then I need to change this baud rate to 9600. And I have something, but it is not really.
How did you run that? See?
How do I run? Here, serial monitor, open, and then check this baud rate. It should be 9600, the same as this.
Yeah. But I get a bunch of
Right, numbers. So what we need to do is that we need to, it goes so fast, right? So we need to make some delay. Delay, say 500. Oops. Oh, we didn't do anything yet, right? Well, we need to save this. After this, we need to save. How do you save? Here, save. Then you need to make sure that where it is now documents and Arduino, right? Make sure that it is there, and then you need to do file name. File name should be my distance, so ultrasound distance sensor, right? Save this, and then we need to compile this. There's icons. Top we have menus. Below we have icons. The first icon, if you move over to that, you move your mouse over to the first icon, then there is an explanation here, annotation. It says verify. Verify means compile. So click this, compile, and watch here to see if any errors. If you have any errors, then you have red colored text. If it is not, then white. Compiling sketch, that is currently going on, right? Okay, so compile is done. So not to. And after that, second icon is for upload. So click this. So compiling, sketching, and uploading. I think uploading is done. And after that, so what it does is here is that this program is now loaded here. Now this guy, Arduino Uno, is running that program. So we need to see, we need to monitor that program. See here, it says, hello, I am here, Neo U. Hello, I am here, Neo U. How often? Every 500 microsecond. So what is the idea of Arduino? Arduino Uno is this. We first set up something that we want. And everything within this loop is running endlessly, 24/7. And now next thing that we need to do is we need to identify these signals, right? So I'm going to close this and see if we have something. We need to. This program does not understand which pin needs to be red, right? Because this sensor send some signals like trigger signal and echo signals. So we need to define that once first. Here, define trigger pin, I said the 13, and pound sign is not a comment in C. Pound sign is one of the program. It's not like a Python. Python's a pound sign is a comment, but here it's a definite. When you do define, then you need to have a pound sign, and then echo. Echo pin is a 12. And in this setup, you have to say pin mode, and then this trigger pin is output, means signal needs to be sent out from your trigger pin, like a chop.
Yeah.
Your sensor needs to chop and then receive echo. So another pin mode, echo pin should be input. This is it. In this way, your experiment is set. And then whatever you want to do, the continual execution or workout needs to be specified in this loop block. In this loop block, there is a digital write. Digital write means I want to write something on that pin, but that pin is an output pin. When I write something on that output pin, it means that points I want to send out the signals. Sending out signal statement here is nothing but digital write. So I want a digital write trigger pin, and then low is some value, so on and off, things like that. Let's do high. Okay, high. And then I will do digital write trigger pin low. And then we need to define here upfront some variable. So long number, you can say duration, all right? And then that duration is nothing but duration is pulse in. That's anything that you see here, the orange color, that is the reserved word. That is a command. That is not something that we choose. Black, that is something that we choose. So that we need to define, for example, duration, trigger pin, echo pin, number 13, 12. They are all something that we pick. Orange sign, that is already defined, but we use it. So we make difference, pulse difference between trigger pin and echo pin. So echo pin and high. I think that is it. Digital right. High digital right high and low. Okay, and see what happens. And then we do serial dot print ln and then duration. And try to upload to see if there's any errors or problems. So done. That's the monitor. See, we have when I move this, see some number, right? There's a distant time difference. When I move slowly out, it's not really. Let's see. Very high, right? If I do this long distance, it takes a longer time. But if I here to this monitor, a little shorter. If I do this to this wall,
But you can't hear what echoes, right?
little longer. Huh?
You can't hear what echoes, right?
No, this is ultrasonic, so we cannot hear. This is not hearable frequency. So those are the microsecond. So we need to compute that microsecond in inch or centimeters. How can we make it? We can make it using this duration. So another long variable, we can say distance. So distance can be computed. Is a duration times 0.34 divided by 2, that's centimeters. So we can say serial dot print ln, and then you can say distance ln. You don't need to do print only space, and then you can do distance.
I think I should have it on the email.
Centimeter. Okay.
I should have it.
So
Is that the code?
yeah, code that I made. Let's see. Okay, that is loaded and monitor. Okay, right now, if I do this to this wall, what is the distance? 87 centimeter, about that, right? So it's less than 1 meter. And then if I do here to monitor, this has some calibration, right? If it is too short, it doesn't understand. So,
Yep.
so something else. You.
1400.
I think this is a light is not really. So 100, a little bit over 100.
Okay, 120.
Yeah, 120. About that, right?
Mm-hmm.
Depending upon the accuracy of this sensor, is that if I put this to the ceiling,
34.
Uh,
3400.
3400 means 3 meter, right? This is 3 meter, right? If I do this to back wall,
It might hit something else.
it doesn't detect yet.
Too far.
Too far. Yeah. So somehow calibration is needed. All right. This is one simple sensor programming. Where's going? Okay.
Are we done?
Yeah.
Oh yeah? I was still trying to make it work.
Yeah. Make it. I'm going to close.